So on this problem, we want to figure out if those those points are all on the same line. Okay, so let's talk about that. I'm going to switch to my dot cam here. Excuse me. And we'll talk about kind of what slope tells us. All right. All right, so slope, like if things are on the same line, if you think here's a line, they all have the same slope. Like you rise 1, run 2, rise 1, run 2, rise 1, run 2. And so the slope would be, you know, like if I have a point here, say, I don't know, say this is at -1, -5. And say my slope is, what I say, rise 1, run 2. So rise 1, run 2. So say my slope is a half. I rise 1, run 2, rise 1, run 2, rise 1, run 2, and so forth. Then I can take this point and I move it. And so, you know, any point right here, the rise and run is still going to have to be that. So if you have the same slope between these points, that means they're all have the same rate. They're all on the same line. Okay, and so that's what we got to kind of test here is see. So what I'm going to do is find the slope between these two, and these two. Now, a lot of times high school teachers love the formula y2 minus y1 over x2 minus x1. And it's okay. It's just kind of, I don't know, harder than it needs to be. I like to do change in y, which is what that's doing, over change in x. And I kind of like to think of temperature, thermometer, something like that when I do it. So I just make an input-output chart and do this. I don't fill in this formula. So let me give you an example. All right, so let's look at these two. Okay, so I'm going to make my input-output chart. 0, -3, -3, -6. Okay, change in y. So let's see what's going on here. The temperature went down 3 degrees, right? It dropped 3. And here it dropped 3. So change in y is this guy, -3, divided by change in x is that guy, -3. And a -3 divided by -3 is 1. Meaning that if I graph these points, right, so where 0, -3 is, you know, down here, and -3, -6 down here, that it would be rise 1, run 1, rise 1, run 1, rise 1, run 1 would be on the slope. So they have a slope of 1. All right, so that's which two? These guys have a slope of 1. All right, let's check these two. Let's see how they differ from each other. Again, you can do this formula if you love it, okay? And I can show you that. It's just I don't love it, but you can do it, okay? So if you love algebra, take y1, -1, minus, you got to be careful, and -6, because you get that double negative there. And then you have to start back at 2, minus whatever's over here, -3, and then you end up with double negatives, right? And double negatives, and you get 5 over 5, which is 1, which is fine. Okay, the thing is, I think it's just easier to make an input-output chart. So there's your input, output, and just do change in y and be like, oh, it went up 5 degrees. Oh, it went up 5 degrees, and take 5 divided by 5 to get that same 1. Students screw this up less. This is easy to make an algebra error with the negatives and double negatives and stuff. This one, you just kind of more common sense. All right, so that's good. These guys have the same rate, okay? Meaning if it's 1 over 1, 1 over 1, it is for these guys too. So now we just have to check the last combination. So these two, okay? And I'll just do it over here. So we have 0, -3, and what's my other point? 2, -1. Okay, so let's see what's happening here. The temperature went up by 2 degrees, and it went up by 2. And 2 divided by 2 is 1. Yay! So what that means is, and I can graph these here, right? If I actually physically graph these, all right? So I have like -3, 1, 2, 3, 4, 5, 6. So here's my -3, -6. I have 0, -3s here, and 2, 1 is here. Well, this is what happens when you just sketch it. Sorry. Not very accurate. Well, let's just try again. All right, I'm not going to put the units on there because, you know, it's not to scale. So I have 1 there, I have 1 there, and kind of have 1 there. All right, but what it's saying is, you know, if I go up, whatever, you know, 5 over 5, or 3 over 3, or if I go 1 over 1, 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 they're all going to line up here. So your slope is your rate. And since they all have that rate of slope of 1, then they all have to be on the same line. All right, so let's go back. Let me get out of my dot cam here. Okay, so let's go back to the question. All right, it says, do the three line up on the same line? Okay, no, because the slopes are the same. Okay, we know the slopes are the same. But that's not a no. I mean, if you have the same slope, you're on that line, right? Let me put that in another context, like a rate. Like, for example, if you make $12 in 1 hour, then in 2 hours you make $24. In 3 hours you make $36. In 4 you make $48. These are all have the same slope, right? Like if you take 12 divided by 1, I mean the rate is the slope is the same, right, on all of these, all right, because they're proportional. They're all at the same rate. So yeah, I mean, I know that's a 48 and that's a 4, but it's still $12 per hour. So the slope is the same. And if I graph these, by the way, right, like 1 would be at $12, 2 would be at 24, 3 would be, they would be on the same line, okay? So these 3 points lie on the same line, yes, because they have the same slope, right? So we will check our answer. Yay, we got it right. All right, hopefully that helps. If you have more questions, let me know. Bye-bye.